All right, welcome back to our second product video. We're going to be digitizing the planar surface of this small enclosure, just so that we could get all the information we need to create a gasket so we can close this up nice and tight. Again, we're going to be using the microscribe digitizing arm, and we're going to be using the Rhino software and the RevWare plugin for Rhino. So there's a few things I want to show you to prep the system before we actually digitize the part. Currently, the microscribe has a 3mm probe on board, and I want to change that over to a point probe so that we can get some of this fine detail as we come along. So let me show you how to run through the probe wizard and do that change. Come up here to the probe wizard. Let's go up here to name probe. I'm going to go ahead and pick on point, and we'll just hit enter, and it will enter into the probe wizard. This device happens to be a 6-off, so I'm going to bring it around into its home position, and then let's run the wizard. It says to home the microscribe with the default tip on board, so we'll bring the microscribe counterclockwise into rotation. We'll hold it there, and we'll say next. It'll say to mount the custom probe, and then we're going to rehome it. So I'm going to just unscrew this 3mm ruby probe, and I'm going to bring the point on board and screw it right in. So make sure that's nice and tight. It says place it into the home position once again, so we'll bring it back around. And again, because this is a 6-off, we will home it, and we'll go ahead and press the next button. So the next thing it wants us to do is to pick up 20 points so that it can find the length difference in any axial deviation there may be in the probe itself. I've got a very small pinhole here on my calibration fixture, and I'll start collecting points. So using the hand trigger, I'll collect points by moving the arm and keeping that point still in one place on my calibration fixture. I want to take a series of 20 or more points. Now it's told me that we have enough points to do the calculation. So we'll go ahead and hit next. It's telling me to put it back in the home position. We will do just that, rotating the 6-off, and we'll say next. So great. All done. We've got a couple checks here that we can take a look at. Let's use the point check just to make sure we've got a good calibration on it. So we'll come right back to that same divot and take a few points. And you can see that we're getting, an average of 0.003 deviation across the spread. So that's more than fine for us to calculate this information for the gasket. So I'm just going to say cancel and finish. All right. Real quick, I'm going to bring up the viewer because I want to zoom in for you so you can see much better what we're doing. And let me make sure that's in the proper position for you to see the part that we're going to digitize. There we go. All right, so let's get started digitizing. Now that we've got our probe all set and ready to go, we will do our alignment. So let's go into the alignment wizard. And first thing it wants to do is measure the plane. I'm going to do something very simple. And we'll say next. And we'll just set up our origin. Well, let's do a couple circles to set up our origin. Let's take this circle here. And then we will say next, and let's set our X direction off of this circle. And we'll say next, and we'll pick up our Y direction with a single point over here. And we'll say next. All right, so now that we've got our alignment established, let's just do a quick reference. Center point, X direction. Yep, we're good to go. All right, so what we're going to want to do is create a curve. We'll just start digitizing a curve. Let's start here on this straight section. So bring our point into place. And you could trigger this to where you could drag it across the part. I've found that you're better to just work your way around, capturing data. Something to keep in mind, you want at least 3 points to constitute any arc. And keep in mind, if an arc doubles back on itself to make a fillet, you need 3 points to describe that. So take plenty of data, try not to back up on yourself, and just keep coming right around the part. When you get to very sweeping wide curves, you can certainly space your points out. You don't need near as much data. Put a duck under this clamp. And we'll get ready to wrap this up. Let's come around this last bolt hole. And I'm going to drop the clicker, and I'm going to come up here and connect to the first point. Let's put the microscope down so it's not trying to take over our mouse. So that's our first set of splines. Let's go ahead and do the inside. So we'll just right mouse click, right back to the same command. We'll start up here on this side. All right, so we're going to come into a pretty abrupt corner. So taking a minimum of 3 points per arc. And we come into the straight section, one more, and then let's just use the dots to connect. So we'll come up here and click on that point. All right, let's pull some holes and we'll be ready to wrap this little project up. So 3-point arcs, we'll just get these 4 circles real quick. Move on to the next one. Third one. All right, because we have been taking all this data in 3D space, I'm just going to go ahead and highlight all this information, do a quick transformation to the seaplane. I'm going to delete all the original data. You can see now it's nice and flat. Let's come over here into the perspective and get a good look at our part. So there you go. There's the gasket information you would need. You could send that right to a cutting table and cut that gasket right out, and you'd have a perfect gasket to meet your enclosure here. So thank you for taking a look at the Microscribe digitizing arm with the Rhinoceros software and the RevWare plugin to make one nice bundled package for doing reverse engineering. If you have any more questions, please do not hesitate to contact us at Go Measure 3D, and we can be reached at 434-946-9125. Thanks, and have a great day.